which is a square prism and axis bisects this one. So find out midpoint of this height, midpoint of this axis somewhere here, and from that draw a square prism like this, such that all the four sides inclined at 45 degree with xy line. After drawing this square, name the endpoints, say A dash, A double dash, B double dash, C double dash and D double dash. Take projections from this side view from A double dash, D double dash and C double dash, horizontal lines. Length is not known to us, so we can take any convenient length and draw the rectangle in front view. Similarly, transfer point from its side view to respective top view by taking projection from here to meter line to here, and the length of this prism would same as the length in front view. So you can transfer these points over here, and this is the front view of this cutting prism. So these are the three views of given data. Now we have to find out the points of intersection and this curve, this line of intersection. You can see here this line. So how to find out that line of intersection? You can see here. For that you pick up this point. So this point is visible in top view somewhere here. In top view, intersection of this square and this edge is this point, and from that point draw a straight vertical line that will cut a B dash and D dash in front view at this point, like this. Similarly, from here on this side also draw a straight vertical line that will cut this line at this point. From here also transfer this point from here to here, that will and locate, draw vertical line from this point, so that will cut horizontal points at these 2 points. So we have identified these 3 points, and similarly on this side also 3 points can be identified. Name those points, A dash, B dash, C dash, D dash on this side also. Now this edge, the yellow edge that is hidden in this red prism. So this edge from this end to this end will not be visible. So draw here with the dotted line this one, and rest all lines with the full line like this. This edge is visible, this edge is visible, and this edge is also visible, so represented by full line. This edge is visible, so represented by full line, and this is also full line. And this portion, inner portion or upper edge of this prism is not visible, so draw that with the dotted line over here and here. This is front view of the problem, this is top view, and this is side view of given problem. If you draw these 3 views neatly and correctly, you will get full 7 marks of this data. 1.5 for this top view, 1.5 for this side view, and remaining 4 marks for this lines of intersection and this front view. I hope the solution is clear to you. Next problem. A cylinder base diameter 50 mm and axis 80 mm long is resting on HP. Its axis is parallel to both HP and VP. The axis is bisected by a sectional plane which is inclined at 45 degree with the VP and perpendicular to HP. Draw sectional elevation, plan and a true shape of the section. Here cylinder is given, so we can draw its top view and front view, but here it is given that its axis is parallel to both HP and VP. It is not lying on its circular face on HP. So in front view the cylinder would appear as a rectangle, in top view also it would appear as a rectangle because its axis is parallel to HP and VP. It will appear as a circle in side view only. If you look from the side, it would appear as a circle. So let me draw the solution of this problem. To draw the solution of this problem, first let me draw its side view. In side view, that would appear as a circle having diameter 50 millimeter. So take 25 millimeter as a radius and draw a circle like this. So this is the side view of given cylinder, and draw its axis. Vertical axis, this one, as well as horizontal axis like this, and draw its front view. So to draw its front view, we can take projection from side view like this, from here also, and from here also we can draw its front view. The length of the cylinder is given as 80 millimeter. So draw a rectangle having width is equal to 80 millimeter and height would be equal to the diameter of the cylinder, that is 50 millimeter. So this is the front view of given cylinder. Similarly, by taking projection from front view, we can draw its top view like this. Take projection from here, take projection from here, and here this is the height, that is 50 millimeter in top view. This is the axis of that cylinder, which is drawn over here. This is the top view. Rectangle. Now it is given that the cylinder is cut by a cutting plane which makes an angle of 45 degree with HP and VP. 45 degree with VP and perpendicular to HP. So angle with vertical plane is visible in top view. So in top view we have to draw a line which makes an angle of 45 degree with XY line, and also it is given that it bisects the axis. So that plane will pass through the midpoint of its axis. Total width is 80 millimeter. So at a distance of 40 millimeter, mark a point, and we have to draw cutting plane in such a way that it will pass through this point and make an angle of 45 degree with XY line. So it should be drawn like this. This angle is 45 degree and this is the cutting plane, and cutting plane is drawn with long dash and small dash like this. Here the cutting edge is there, so it is fully drawn, then long dash, two long dash and one much longer dash. That is the symbol of cutting plane, you can see here. So this portion is cut. Now you can lighten this remaining portion. This is a removed portion. So only this much cylinder retains with us after cutting at given angle and from the given point. This is the remaining cylinder. If we cut the cylinder from here, what would be its front view? That we have to draw. So for that, again we have to draw imaginary generators over the periphery of the cylinder, and for that let me draw its side view or a semicircle to the left side just to find out the points, and divide this circle into 8 equal parts. This circle also this semicircle into 8 equal parts from here and here, and similarly from here, and draw these imaginary generators over the periphery of the cylinder like this. From here draw a line, this is imaginary generator. Similarly from here like this, and on this side also from here take projection from here, and this is imaginary line, and from here also take projection. This is an imaginary line. So we have drawn all imaginary lines in front view as well as in top view. Now pick up the points of intersection. For that, name the points. Say suppose this is point number 1, here is point number 2, 3, 4, 5, 6, 7 and 8. Similarly, one point would be here, 1, 1, 2, 3, on 1, P1 point would be here. You can see here point number P1 on 1. So intersection of edge 1 and P1 is here. So from this point draw straight vertical line that will cut 1 dash at this point. This is point number 1 dash. Similarly point number 2 would be here, 2 days, 3 days, 4 days, 5 days, 6 days, 7 days and 8 days. All 8 points are there. So this is first point. Point number 2 is on point number P2 is here, P2 on 2 generator. So from point 2 draw a straight vertical line like this that will cut generator from 2 days at this point and generator from 8 days at this point. Now for this point draw straight vertical line like this that will cut 3 days at this point. Here is point number P3 and 7 days at this point. You can see here P7 days, P3 and P7, 2 points are here, P1, P2, P3. Similarly here point P4, here is point P5, then P6, P7 and P8. 8 points are there. Locate all these 8 points on this top view by drawing vertical lines from here. So here point number P1 is here, P1 days, here is P2 days, P3 days is here, P4 days is here, here is P5 days, P6 days, P7 days and P8 days. All points are drawn over here. Now as it's a cylinder, you join all these points with a smooth curve, because these all points should be joined with the smooth curve because it's a cylinder, and cylinder is cut, then its curvature shape would be there. So it would appear like this. If we join with the smooth curve, after joining this with the smooth curve, this portion, this outside portion is not visible, it is cut portion, so that should be erased because it's a cut portion. So it's erased like this, and this remaining portion which retain with us, so which is shown here, over here with darker color like this, and here section lines would be there because it's a sectional front view. So this is the portion which remains with us if we cut at an angle. Similarly here this portion would retain with us, which is shown with some darker color, this one. This is the cylinder retained with us. So if we cut this cylinder, it would appear like this in top view, it would appear like this in front view. Now how to draw its true shape? So for that we take projection from this P1, P2, P3 like this. Draw straight vertical lines from all these points, P1, P2, P3, P4, P5 and P6, P7 and P8. This line should be drawn in such a way that it becomes right angle to this reference line. This angle should be 90 degree. And draw a line at any distance parallel to this cutting plane line. This is called as auxiliary plane line, that is X1 and Y1, auxiliary plane line. And measure the distances of respective point in front view from XY line. So for that point number P1, P3 would be here, and measure this distance. For P1 point is here, XY to P1 is here, so measure this distance from on P1, mark a point over here. So this is point number P1, so it would be somewhere here. Point number P1 would be here. Similarly mark point number P2. For P2 measure the distance XY to P2 over here. This is the distance on P2. Here point P2 is there. So draw and cut an arc. So this is the point P2. P3 is on XY line. P4 is at the same distance where P2 is there, somewhere here. P5 is here. Measure this distance, P5 days, XY line to P5 days. and the xy line to x1y1 line to p5 dash somewhere here. Similarly, xy line to p7, xy line to p7 somewhere here. So these are the points of intersection for all these points, and join all these points with a freehand smooth curve. It would appear like this. By doing long practice, you can draw a very smooth curve. Initially it would be difficult for you to draw a smooth curve like this, and here you can draw section lines to show that it's a true shape. Draw lines equidistant which makes an angle of 45 degree with the reference line, and you mention the name of views. This is front view, this is top view or plan, and this is sectional true shape of the section. True shape of the section. This problem is asked for 7 marks. So 2 plus 2, 4 plus 3. 7 marks is the distribution for this solution of the problem. And you mentioned answer 3A or just 3A with the big letters. And you can insert the dimensions in the given figure as well. So I hope the solution of these problems are clear to you. And if you have any problem, we will discuss the same problems in the next coming session, and wish you all the best for your exams.